Okay, so the video glitched out, so I'm going to pick up where I left off in the last one. So symmetry, again, has y-axis symmetry, which means the function is even. Again, the way we show a function is even algebraically is we take the opposite of the input value, we take f of negative x, and show that it gives us back the original function we started with. Okay, horizontal asymptote here, once again, is y is equal to 0, and the vertical asymptote is x is equal to 0. Now, I want to go back to discuss the x-intercepts and the vertical asymptotes really quickly. So just as we had with polynomial functions, when we have x-intercepts for polynomial functions, the multiplicity of the x-intercept dictates whether the graph touches or crosses the x-axis at each x-intercept. And that is going to hold true for rational functions as well. Okay, so if you take a look at the note that we made over on the side here, you want to write this down. This is going to be really important for us when graphing rational functions. The multiplicity of the zeros in the numerator tell us if the graph touches or crosses the x-axis at each x-intercept. Okay, so if your numerator in lowest terms has zeros with odd multiplicity, the graph is going to cross the x-axis at the x-intercept. And if it has zeros of even multiplicity, the graph is going to touch the x-axis at the x-intercept. Okay, now the multiplicity of the zeros in the denominator tell us something as well. Okay, so the multiplicity of the zeros in the denominator tell us if the graph goes in the same direction or opposite directions at the vertical asymptote. Okay, so again, the multiplicity of the zeros in the denominator tell us if the graph goes in the same direction or opposite directions at the vertical asymptote. So when I go back, I'm gonna take a look at the two functions that we looked at the graph of earlier. Sorry, I'm gonna just erase this really quick. Okay, so the function 1 over x graphically looked like this. So when we look at that function 1 over x, again, that rational function is in lowest terms, okay? And when we look at the multiplicity of the 0 in our denominator, the multiplicity of the 0 in the denominator is 1, it's odd. So when that happens, your graph is going to go in opposite directions at the vertical asymptote. So when I look at the vertical asymptote, on the right-hand side, it goes to infinity. When I look at the vertical asymptote on the left-hand side, it goes to negative infinity. Okay, and now you don't know like in what direction the graph goes. Like you don't know what side goes to infinity, what side goes to negative infinity without actually plugging numbers in. But you do know that the graph has to go in opposite directions when the 0 in your denominator has odd multiplicity. When the 0 in your denominator has even multiplicity, like the function g of x equal to 1 over x squared, that means that as you approach the vertical asymptote from each side, your graph is going to go in the same direction. So in this particular case, as we approach that vertical asymptote at x is equal to 0 from both the left and the right, both sides go to infinity. It's also possible, depending on what your function is, as you approach a vertical asymptote with even multiplicity, that both sides of that asymptote go to negative infinity as well. Okay, so again, you have to plug numbers in to see whether both sides go to infinity or both sides go to negative infinity, but what you do know is that both sides are going to go in the same direction. And that idea is really, really important when it comes to graphing rational functions. Okay, so we are going to move on to the next video, and the next video will work out the remainder of the properties of rational functions to complete this part of the lesson. And again, these properties of rational functions are extremely important when it comes to graphing rational functions. So spend some time reviewing this video before you come to class for the next meeting. And if you do, and if you understand these properties really well, it'll help you graph rational functions much more easily.